Welcome to this presentation on the structural analysis of a simple bridge, focusing on the influence lines for shear force and bending moment. My name is Edwin Madera and I'm currently an undergraduate student pursuing a major in civil engineering. In this video, we will explore how moving loads impact the reaction and internal forces within the bridge structure. So let's dive into it. The objective of the structural analysis is to understand influence lines for shear and moment at a specific point on the bridge, subjected to an HS 15/44 drug live load. I implemented both theoretical calculations and MATLAB to achieve accurate results. The specific point that we will be focusing on is point C in the beam shown in the image. Here I provided the lengths that were provided in the assignments. Well, the two cases were examined with different span lengths, included case 1, L3 equals 30 feet, and case 2 equals 50 feet. And it was mainly to see how the length of the span affects the shear force and bending moment at point C on the bridges. I also included beautifully drawn influence lines for each of the cases. Now let me get into how I came up with these influence lines and what methods and principles I used. Well, the analysis relied on two fundamental principles, which is the statics method and the Mueller-Breslau principle. Now, these two methods help us derive accurate influence line functions and visualize the deflected shape of the structure under the load. Using the statics method, I was able to calculate the influence line function for shear and moment at point C for both cases. And the Mueller-Breslau principle served as a verification of using the statics method. Now keep in mind, in these images I only included a couple of span length functions for case 1 as well as the influence line for case 1. Now further along I will show you all the functions that I was able to revise for both case 1 and case 2. Well, to automate the calculations and visualizations process, the derived functions were implemented in MATLAB. And here I include all the derived functions for each range or span length for case 1 and case 2 in shear and moment at C. And this just allowed me to compute influence lines efficiently and accurately, providing clear visualization of the results, which I do include in the next slide. But here I do include part of my MATLAB code, which I start with initializing the variables, using for loop to display each case, and I display results using plots and subplots. Now, do keep in mind that I only included the screenshots from MATLAB for case 1 of the code. You would have to repeat the same exact process for case 2 with the derived functions. And after running the MATLAB code, I was able to get a couple of results. These results included in case 1 where the shear influence line shows a peak of 0.5 just to the right of point C, while the moment influence line peaks at 15 at point C. In case 2, the shear influence line remains consistent, but the moment peak increases to 25. Well, the challenges that I did face were in deriving the accurate functions using the statics method and implementing the code, which the for loop I needed to go back to one course I took previously to really understand the process of using the for loop again. But by using these methods, I was able to address those issues and achieve reliable results, to say the least. And these are the MATLAB displayed plots from each case. And overall, the analysis provided valuable insights into the structural behavior of the bridge under moving loads. In other words, the influence lines that we calculator computed in MATLAB, we're able to visualize and understand how the moving truck would affect point C. And once again, the robust framework we developed ensures accurate design and enhances reliability and safety of the bridge. And that is all I have to say of this topic. The references are included below. Um, yeah, thank you for watching. If you have any questions or would like to learn more, please feel free to leave a comment. Otherwise, like and subscribe for more. Thank you.